In this lesson, we are going to talk about slope and proportional equations. Now, we've talked about these two concepts in the past, but we're going to do a nice little review. All right, let's talk about a proportional equation. A proportional equation uses the formula y equals mx plus b, and that formula is going to construct a line on the coordinate plane, just like the one that you see here in the picture. Now, something important to know about this y equals mx plus b formula is this variable m. And in the past, we've talked about this m. This is called the slope. Slope is also basically what it is it's the steepness of a line. So the bigger that number is, the steeper the line is going to be. We can also recognize slope as this idea of a rise and a run. And what that means is this. If we look over at our coordinate plane, if we want to go from one point to another point, to determine the slope, we would use the rise and the run. So for example, if I start right here with my pen and I rise 2 and I run 2, well, 2 divided by 2 is equal to 1. And you can see that over here on the right-hand side. Let me change my pen color here. But you can see that my slope is broken into my rise and run, which is 2 divided by 2, which simplifies to 1. So the slope of this line is going to be a 1. Now, it's not always going to be 1. It just is in this example. We can also recognize the slope as this thing called the change in the y over the changes in the x. And really what that means is what we just did. The rise represented our changes in the y direction, and then the run represented our changes in the x direction. So just doing a little bit of review of what we learned in the past. Now to bring it back to this idea of a proportional equation, we can say that y is equal to 1 times x, as you see right here. Now 1x is, you may recognize this as, well, we actually don't need to we don't need to represent that 1 there. So we can actually just write it as y is equal to x, and it means the same thing. So what we're going to be doing today is constructing these proportional equations. Now, you might ask yourself, well, what about the b? What do we need to know about this b back in the formula? Well, that's going to be what we talk about in the next section. What it is it's the y-intercept of the line, but you don't need to know that at this moment. All right, now that we reviewed the concept of slope and proportional equation, let's go ahead and try a couple more. All right, with these two given coordinate planes, you can see that they both have a graph on them. Notice that the graph has several points on the line, and notice that the line has these little arrows at the end. The little arrows means that those lines are going to go in that those opposite directions forever and ever. It's never going to stop. So what we want to do first is just determine the slope. We want to just determine the m variable. So to do that, we just need to select 2 points. So what I'm going to do here, I'm going to go ahead and change my pen color so you can see it. I'm going to choose 2 points. I'm going to go ahead and choose this one right here and this one right here. Now, in order to find my slope, I need to rise and run. So I'm going to start here and I'm going to rise 1 and I'm going to run 2. So you can see I went up 1 and I went to the right 2. So that's going to give me 1 over 2. Well, we need to ask ourselves, does 1 over 2 simplify? And it does not. So therefore, our slope of this line is just 1/2. Now, you might be wondering, well, what if I chose 2 other points? What would that look like? So let me go ahead and change my pen color. Let's change it to green here. Let's go ahead and select this point right here. And let's go ahead and let's just select the origin. Why not? Let's do a rise and a run. So I'm going to start here and go rise up 2, and I'm going to run 4. So that's going to simplify down to 2/4, right? Well, 2/4 isn't reduced, so we need to actually take that further and simplify that down to 1/2. Notice that no matter what 2 points that I use, I'm still going to end up with the same slope of the line. Let's try another one. Let's try the next one over to the right. Okay. Let's go ahead and choose, I don't know, let's just go ahead and choose this point right here and this point right here. Let's go ahead and rise and run. You can see that I rose up 2 and I ran over 1. Now this is a little bit different now. You can see that 2 divided by 1 simplifies down to 2. So the slope of my line here is 2. A little bit different than the one before. Now, if you look at these two lines, can you see that the one on the right-hand side has a bigger slope, meaning the number 2 is bigger than 1/2? Well, because that number 2 is bigger, you can see that our line is steeper. Now, what if we chose 2 different points here? Let's go ahead and choose the origin and this one way up here. Let's go ahead and try it using those 2 points. So I'm going to rise. How many points is that? 1, 2, 3. It looks like 4. And I'm going to run 2. So let's go ahead and do that. 4 divided by 2. Well, that simplifies down to 2, which is the exact same thing as what we did before. So it doesn't matter what points you use. Okay. Now, I do want to go back because I actually didn't finish the problem. What I want to do now is I want to construct a proportional equation for each one of these. So for the first one, what we're going to do is we're going to put this in the form y equals mx, or y equals mx plus b, but we haven't talked about that b yet. So let's just do y is equal to mx. We know that our m is 1/2. So let's go ahead and put it in here as y equals 1/2 x. That is our proportional equation. And just as a reminder, all proportional equations are going to run through the origin. And the origin is that point that is right in the center there. That's the origin. Okay, how about the second one? The proportional equation, we're still going to put it in the form y equals mx. And let's go ahead and say, well, our slope is 2. So we're going to put it in as y equals 2x. And that's it. That's our proportional equation. Now, what this says is this. This proportional equation is this graph right here. It represents this graph if we were to give it a name per se. Same idea with this one. It gives it a name. All right, now that we've talked about that concept, let's go ahead and let's talk about a table of values because we want to pull that in here as well. Every graph that's on a coordinate plane has a table of values because it has coordinate points. So let's look at this first example. Here I just give you this proportion, right? 6 divided by 3 equals 10 divided by 5. We can see that the 2 top numbers represent my y's, and then the 2 bottom numbers represent my x's. So if we were to simplify these, you can see that 6 divided by 3 over here is going to simplify down to 2, correct? And then 10 divided by 5 is also going to simplify down to 2. Okay, so if we were to use, coordinates and we were to simplify the slope down, we could do it that way. Now, let me show you another way here because not only is the formula y divided by x going to give us our slope of a proportional equation, but watch this. I'm going to go ahead and take those x coordinates and I'm going to go ahead and pop them into my table of values. So I'm just going to put a 3 here and I'm going to put a 5 here. Then I'm going to take my y values and I'm going to go ahead and put those in there as well. And I'm going to match up my 6 with my 3 and my 10 with my 5. You can look at a table of values and you can actually use something called a multiplier to determine the slope of the line. So for example, if I were to look at the 3 and the 6, if I were to multiply the 3 times 2, that would give me 6. Same thing with the 5. If I were to multiply the 5 by 2, that would also give me 10. Therefore, the slope of my line is going to be 2. So that's just another way to figure out the slope of a proportional relationship. Sometimes we also call this multiplier, not only do we call it slope, but we also call it this name, the rate of change, the rate at which the problem is changing. So if you hear slope and rate of change, it just means the same thing. Now let's go ahead and take that number and let's just pop it right into our proportional equation, y equals 2x. All right, so let's try an example of this. Here I'm given 2 coordinates, 3, 9, and 4, 12. And it says fill out the table of values. So I'm going to go ahead and do that. Remember that this is my x and this is my y, and this is another x and this is another y. So I'm just going to go ahead and pop those into place. 3 goes with 9 and 4 goes with 12. And I want to ask myself, what is my multiplier? So to get from 3 to 9, I need to multiply this by 3. To get from 4 to 12, I need to multiply by 3. That number should be exactly the same. So my slope is going to be 3, or my rate of change is going to be 3. Okay, Now let's talk about this new word, okay? The word is unit rate. It says determine the unit rate. Unit rate is just another way to say rate of change and just another way to say slope. That's it. Remember we talked about way up here that when you take y divided by x, it equals the slope? Well, that's what the unit rate is. So let's go ahead and take the y value. Let's take 9 and divide it by 3. We know that that's going to equal 3. We also have 12 and 4. And if we divide them, that's going to give me 3. So 3 over 1, which is going to simplify down to 3. So that means that my proportional equation will end up being y is equal to 3x. Okay. Now let's go ahead and practice a couple problems here. It says, given the table, determine the slope and write the proportional equation. So we're trying to figure out slope, which is our variable m, and we're trying to figure out what the proportional equation is. So we can really do this any way that we've learned in the past couple slides. Here we're given a table of values. So let's just think about this. Couldn't we use the unit rate to determine the slope? The unit rate is going to be y divided by x. So what you can do here is take any two coordinates that you'd like. Let's go ahead and take the bottom coordinate, 2 and 6. So I'm going to pop that in, one for my y and one for my x, and I'm just going to simplify it down to 3. Therefore, the slope of my line is 3. I also could have taken this value. Instead of the 6 and the 2, I could have taken the -1 and the -3. So -3 divided by -1 is equal to 3. No matter which point that I take, that is, it's going to work. Now you might be thinking, well, what about this coordinate here, the 0, 0? Well, that right there is the origin. So remember, all proportional equations, they all run through the origin. So when you see that 0, 0 there, then you know you're on the right track because you know it's going to go through the origin. Okay, let's go ahead and come up with the proportional equation now. Y is equal to, I'm going to pop my slope in there, x, and I'm done. What that means is these coordinates over here in the table of values, these coordinates are going to land on a line, and the line that they're going to be on is the line y equals 3x. Okay, now let's go ahead and look at this again, and let's go ahead and let's do our y over x. This is our unit rate. Y divided by x equals, I'm just going to go ahead and I'm going to pick this point right here. I'm going to say 4 divided by 6. Well, that's not simplified, so I actually have to simplify that down to 2/3. And 2/3 is going to be my slope. All right, now let's go ahead and come up with the proportional equation here. Y is equal to 2/3 x. And it's perfectly fine if the slope is a fraction. Now, I just want to go back up to the beginning question here because you might be thinking, well, couldn't I use the multiplier? Sure. If you recognize that -1 times 3 is -3 and 0 times 3 is 0 and 1 times 3 is 3 and 2 times 3 is 6, well, that's just another way to recognize that slope. But for the second example, it might be a little bit hard because this is saying that 0 times 2/3 is equal to 0. 3 times 2/3 equal to 2, and so forth. Sometimes with fractions, it's a little bit harder to recognize that, which is why the unit rate might be a little bit more helpful to you. But both of them work perfectly. All right, let's go ahead and try some word problems or some practical problems using this concept. The first example, Claire runs 5 meters every second. Well, let's just stop there. Whenever a problem says every second, that just means for every 1 second. That's all. If x represents the number of seconds and y represents the number of meters she walks, write a proportional equation showing this relationship. So here's our goal. We want to write a proportional equation showing the relationship. So let's go ahead and fill in the table of values first. We know that for every 1 second, Claire is going to run 5 meters. So for 1 second, 5 meters. What about 2 seconds? Can't she say if for every 1 second she runs 5, can't we say for every 2 she's going to run 10? And for every 3 she's going to run 15? And for every 4 she's going to run 20. So 2 ways you could do this now. You could use the unit rate or you could use the multiplier. Let's go ahead and use the multiplier first. 1 times 5 is going to give me 5. 2 times 5 is going to give me 10. 3 times 5 is 15, and 4 times 5 is 20. So you can see that multiplier there is 5. That means my slope is going to be 5. I could have also used my unit rate. Just pick a point. Let's go ahead and pick 315. 15, which is my y, divided by 3, which is my x, is going to leave me with 5. So you can see that no matter what, my unit rate or my slope is going to be 5, which means I can say that my proportional equation will be y is equal to 5x. And we're done. Let's try another one. Okay, in this example, Dean takes an Uber to school. The driver charges him $3 for each mile he goes. If x is the number of miles and y is the number of dollars, write a proportional equation representing this relationship. So, okay. Again, up here it says each mile. So isn't that going to be for every 1 mile? We're also looking for a proportional equation. So let's go ahead and fill in our table of values. For every 1 mile, the driver is going to charge him $3. So how about 2 miles? How much is 2 miles going to cost? 6. 3. 9. And 4 is going to be 12. All right, so we could use our multiplier, couldn't we? I'm going to go ahead and grab my green pen here. We could use our multiplier. I'm going to multiply it by 3. That's going to give me that, that slope, which is going to be 3 in our case. Or I could use the unit rate. I could just pick a point. I'm going to go ahead and pick for 12 and say 12 divided by 4 is going to equal 3. That's my unit rate. So I can go ahead and construct my proportional equation now. Y is equal to 3x. All right, so those are 2 practical problems using this concept. I have one more thing to show you before we dive on into something new, and it's how do you graph something like this? What if you have a slope and you have a point, and they're asking you to construct that proportional equation on the coordinate plane? Well, if you plan to do that, you always need to start with your coordinate. That's this guy right here. The 1 is an x and the 2 is a y. So if I have an x and a y, let's go ahead and plot it on our coordinate plane. That's going to be right about here. Now, my slope is 2/3. Remember, a slope can also be written as rise over run. So I'm going to take that point and I'm going to rise 2 and I'm going to run 3 and I'm going to draw a little dot there. And I'm going to continue that pattern on my coordinate grid. Now, you can see that I've gone to the right. Now I need to go to the left. Now, to go to the left, it's a little bit different. You have to think about it like this. 2/3 I can also write as -2 over -3, right? Because -2 over -3 still simplifies down to 2/3. And the reason is a negative divided by negative is a positive. So I can go down 2 and to the left 3 if I'd like and continue that pattern. So down 2 and to the left 3. Down 2 and to the left 3. You can see that it continued that pattern on my coordinate grid. Now, anytime that I have a line or I'm constructing a line like this, I want to draw a nice straight line, preferably using a ruler, with little arrows at the end of my line indicating that this is going to extend in both directions forever and ever. Let's go ahead and try another one. In the second one, you can see the coordinate -2, -6. Well, -2 represents my x value, and then my -6 represents my y value. So let's go ahead and take a moment, and let's go ahead and plot that point. -2, and then 1, 2, 3, 4, 5, 6. There we go. My slope is 3. Now, remember, slope is a rise and a run. So you have to kind of think about 3 is not necessarily a fraction, but I could make it a fraction, couldn't I? Couldn't I just put 3 over 1? That would give me a rise of 3 and a run of 1. So there it is. Rise of 3, run of 1. Rise of 3, run of 1. I continue that pattern all the way off of my coordinate grid. There it is. Those are all the points that are going to fit on my coordinate plane, so I'm just going to go ahead and stop there. I'm going to grab my ruler, and I'm going to go ahead and draw a really straight line going through each one of those coordinates and little arrows at the end. All right, excellent. Now, just looking at this, look at the 2 different graphs that I have here. Do you notice how the second one is steeper than the first one? Well, the reason is the slope is bigger. 3 is much bigger than the fraction 2/3. So therefore, you can see that the graph is going to be a little bit steeper or harder to climb. All right, that brings us to the end of our lesson on slope and proportional equations.